This video will review over how to perform titration calculations. Now, titrations are lab procedures used to determine a concentration of a solution. Titration reactions are typically performed between an acid and a base. An indicator chemical will be added to the solution to signal when the endpoint is reached. The endpoint will be identified when we see a color change. Now, when we have a titration as an experimental setup, the glassware that we will work with is called a burette. The burette will have a given amount of chemical in it, either the acid or the base. The Erlenmeyer flask will contain a solution to be titrated, and it will contain the indicator. We will add the chemical from the burette drop by drop until we see a color change occur within the flask. This will signal the point of neutralization, and we can use the amount of the chemical in the burette and the amount of the chemical in the flask to mathematically calculate the strength of our unknown chemical. So we will know the amount of acid and base used in the experiment, and we will know the strength of either the acid or the base. The titration is done to calculate the strength of the unknown chemical. In a titration reaction, we will measure the volume of a standardized solution, for example, sodium hydroxide, that reacts stoichiometrically with an acid. In the acid-base reaction, we will balance the equation, and we will use the concepts of equivalence. We know at the end point of the titration, the number of equivalents of base will equal the number of equivalents of acids. Here we have an example titration problem. For the acid-base titration combination of nitric acid with potassium hydroxide, determine the number of moles of nitric acid that would be required to react with 0.75 moles of potassium hydroxide. The approach to solving this problem is first we must write a balanced equation. Well, we have nitric acid plus potassium hydroxide. This is a double replacement reaction, so our positively charged potassium and our positively charged hydrogen will trade places. That results with HOH, hydrogen plus 1, OH negative 1, and potassium nitrate, potassium plus 1, nitrate negative 1. We check our equation out, and yes, it is balanced. Step 2 is to convert moles of chemical A to moles of chemical B. It is a simple stoichiometry problem. Now, we will start with our 0.75 moles of potassium hydroxide as chemical A. We will do a mole-mole ratio of potassium hydroxide and nitric acid. Moles of potassium hydroxide cancel out, and we are in moles of nitric acid. So our answer would be 0.75 moles. Here we have a titration problem where we have 15 milliliters of 0.025 molar aqueous sulfuric acid that is required to neutralize 10 milliliters of aqueous potassium hydroxide. What is the molarity of the potassium hydroxide? The first thing we must do is to write a balanced chemical equation. Secondly, we will convert our liters of A to moles of A. Thirdly, we will convert our moles of A to moles of B using a mole-mole conversion. Finally, we will determine the molarity by calculating molarity as moles divided by liters, so that the molarity of B will equal moles of B over liters of B. So we begin by writing a balanced chemical equation, H2SO4 plus KOH gives H2O plus K2SO4. Potassium plus 2 sulfate negative 2. We then go back and we balance our equation. We have 2 potassiums, therefore we need 2 potassiums. This gives 2 OHs. We add the 2, gives 2 OHs. That gives 2 hydrogens. We have 2 hydrogens. We are now balanced. We will convert our liters of A to moles of A. Our problem stated we had 0.015 liters of sulfuric acid. We will multiply that times the molarity, which is 0.25 moles per liter. This allows us to cancel out of liters, and we are now in moles. We have now calculated the moles of H2SO4. Our next step is to convert from moles of A to moles of B. So we take our 0.000375 moles of H2SO4. We use our balanced chemical equation and our coefficients. We have a coefficient of 2 in front of the KOH. We had a coefficient of 1 in front of the H2SO4. This allows the moles of H2SO4 to cancel out. We now have our moles of KOH. Now it's time to calculate the molarity. Remember, molarity is moles divided by liters. We've calculated our moles. We have our liters. We divide moles by liters, and we now have our molarity of KOH. Do study this problem, as you will have several of these on your homework and on your upcoming test.